So this first unit of geometry is really about learning the language of geometry. And so that's why we've called it building blocks. All of the pieces we find now continue throughout the course. So really work to pay attention to the new vocabulary, the notation, the naming, because it's really the essential way to be able to talk the geometry talk as we move through this course. So in section 1, we're going to talk about lines and angles, and we have 2 learning goals this unit. We want to be able to identify key terms and identify them in diagrams, and we want to be able to identify different types of angles, know their properties, and then use those properties to solve problems. So that's what you should be able to do when we finish this unit. So some naming things, and it might seem strange to talk about naming, but geometry is a very technical mathematics, and you got to be able to name things and understand the notation correctly. So a line is made of any 2 points, and it's infinite in both directions. So that's something you're probably fairly familiar with. When it comes to naming a line, there are 2 ways to name the line. You use any 2 points on the line with the little line symbol above it, and the order does not matter in a line. So line XY is the same as line YX. Sometimes when you see a line, there will be like a cursive lowercase letter by it. You can also name this line G. Now we would never mix that lowercase with an uppercase. We would never say GY like this. Okay, so it's either just lowercase or 2 points. A segment has length. Okay, it has starting and ending points. So whereas a line continued infinitely, a segment has a finite length. So when we go to name that, we name with the endpoints. So this is AB with a little segment above it, or BA. Again, the order doesn't matter. We just must name it with the endpoints. A ray has a fixed endpoint, or starting point would be better, and it goes infinite in the other direction. Now this time when we name, it gets a little bit more specific. So when we go to name it here, you always start with the fixed point and then any point in the direction it goes with the little line. So if there were a point F right here, we could also name that exact same ray DF. So the same fixed starting point and then kind of the directional point. What direction is our ray going? Now angles have 3 different ways to name them. So first of all, we talk about this is our vertex. It's the corner of the angle. This and this are called the sides. Okay, 2 rays make up the sides. There are 4 ways to name an angle. So the easiest way is by the vertex, angle Q. That has some limitations. If, for example, I have this picture where there are multiple angles, I can't use the naming angle Q here because I don't know if do I mean this angle Q? Do I mean this angle Q? Do I mean the big angle Q? It's not specific enough. But in our example picture, it works because there is only one angle. Sometimes there will be numbers in the vertex corner, and we can name the angles by their number. The other way we name angles is we keep the vertex in the middle and we use any 2 points on the sides. So we could say angle RQP, see how that vertex is in the middle? Or we can go the other way and we can say angle PQR. And those are all the same angle. This is a very important concept as we move forward in this course. A couple of definitions here of collinear and non-collinear, exactly kind of what they look like. Co means together, line. So this is 2 or more points on the same line. So no surprise, non-collinear means not on the same line. So again, just being able to describe what a picture is doing and how points are in relation to each other is really important in geometry. These notational pieces that I'm going to go through next are very, very important because it's how we get information from a picture. So it's kind of like learning to read a picture. Just like we learned to read when we were in elementary school, we're going to learn how to read mathematics. So congruent is kind of a fancy word for equal, and it's segments with the same length. They can be twisted, they can be turned, they can look different in their setup, but if you see the notation, you know it means they have to have the same. So the notation we would have is you might have a picture like this, and we would have segment AB and segment CD. And so one way that we would talk about this for notation is we would talk about segment AB is congruent, it's an equal sign with a little wave over it, is congruent to CD. On the picture, you will see hash marks. And if you see 2 hash marks on pieces, any pieces that have 2 hash marks or 3 hash marks or 1 hash mark are congruent. Same thing with angles. They're going to have the same measure, the same size, the same degrees. And so if we had a couple of angles here, and we could call this angle A, and we'll call this one angle B, and then we'll have another one that we'll call angle C. Now, if I want to write it, and I had hash marks like this, based on those hash marks, I know that angle A is congruent, again, equal sign with a little wave over it, to angle C, because they both have 1 hash mark. Angle B has 2 hash marks. It is a different size. So again, the hash marks and the little congruent symbol. Parallel is something that you've probably seen before, 2 lines which do not share a common point. And so if we have our lines here, we never assume anything in geometry. If this was G, H, and K. I don't know if those are parallel or not unless there's information given to me. And the way I can tell it from a picture is there will be little arrows or triangles on the picture. So from this picture, I can say that G is parallel to H. Excuse me. G is parallel to H. There's no markings on K, so I cannot assume that it is. And then the parallel notation is just 2 little lines that look like they're parallel. Perpendicular are lines meeting at 90 degrees. And so when we see that picture, we will see a couple of different notations. If we call this little line M and this one is N, in a picture, you'll see that little box. So then what I can write is that N is perpendicular to M. So you should be very comfortable moving from the word sentence to the picture or the picture back to the word sentence. So that's how we talk about notation. So let's look at a couple of examples quick. This picture is very typical of geometry, and I want to know, can we know the information for sure that's below based on the picture? So can I know that UV is parallel to UT based on what's given? So VW is right here, and UT is right here. And when I look, there are no additional markings, and so I do not know, and I cannot prove that those lines are parallel based on the given information. If I look down to angle WVU and angle TUV, we go back here and we mark them so we can see them. WVU, W to V to U, that's this angle, and T, U's the vertex up to V, this angle right here, are they equal? And these hash marks right there tell you, yes, those are congruent based on the picture. We never assume anything, but those hash marks in that picture tell me that that information is true. The next one is that WV is equal to UT. So where is WV? W to V is right here. U to T is right here. There are no hash marks on those segments, and so I have no way to prove that those are congruent. And then the last one asks me about perpendicular. And it says, is line B perpendicular to C? And so here is B, and here is C, and that is also no. Those two lines might be parallel, they might not be, but I don't have any information to say that they are or are not. So that is kind of how we apply the notation to pictures. If we look at the next one, we want to list the information it gives us. So the first thing I see are those two, and then I would write that XW is congruent to VU. And if you do WX, that's totally fine. So there's one piece of information. Here, I'm being told parallel. So my next piece of information that I can do is that C is parallel to D, because I can use these lowercase letters to name it. The last piece of information from this picture is that right there. And there's a couple of ways that I can make that notation, and they're all the same. I can say that VU is perpendicular to line E. We don't like to do that. That's not a great one with the points and the lowercase, but it is what we're given. So we can write that. We can also talk about this as being a 90-degree angle. It's kind of hard to name because we're missing a point here, but if I make this a point M out here, another way to say the same piece of information is that angle VUM equals 90. So you can get all of that information from the picture. So that's the first part of this lesson. Please tune into the second video for part 2.